Hello everyone and welcome to our virtual field day. My name is Caio Canella. I'm a PhD student at the University of Missouri working on soybean breeding and genetics. Today I'm very excited to share our new project on soybean tolerance to off-target dicamba damage. So this project really started by our own observations in the field and seeing how our plots were responding differently to this off-target dicamba damage. So as you can see in the picture I'm showing here, we have this line on the left, which is an extend check. So it's free of symptoms, completely healthy plant. On the far right, we have one conventional line that is highly susceptible. So you can see all the symptoms being shown. However, the one in the middle, this is a conventional line, but it had very minor symptoms to dicamba. And we have been observing this across several plots and several different locations. So because of that, we decided to further investigate and see if there was any genetics underlying this trait and really if this would impact in yield by the end of the season. So from 2019 and now in 2020, we have been screening over 10,000 plots for their response to off-target dicamba damage. So those plots represents our lines developed at the University of Missouri. So we have roughly 450 of those, but we also have what we call mapping populations. So we develop populations to really understand the genetics underlying this trait and identify what is really causing this differential response. The way we've been doing this until now was from a 1 to 5 scale, where 1 represents the minimum damage, no symptoms of dicamba, and 5 represents the maximum damage, so where you observe the most pronounced damage from dicamba. But starting this year, we decided to take a different approach and make our screening even more large scale. And as you can see from this picture, we've been using a drone to help us to collect the data. And just from this, you can see a little bit the perspective and the size of this research. So in this short video, this represents one location for one of our tests. We have probably 10 or more of this, so the drone really comes handy to help to collect all this data. And how we do that is we take several hundreds of pictures per location. So the drone pretty much takes a picture every 2 seconds. And then after we complete the flight, we have a software that is responsible for putting all those pictures together. So it's a process we call stitching, and then we're able to generate one single map by combining all those pictures. And whenever we have this map, we can now start playing with the sensors we have on our cameras. And as you can see from this picture here, the one on the right is one of the methodologies we've been using to differentiate tolerant to susceptible lines. So the more yellow line, as you see in this plot here, this is a healthy vegetation. So you expect minor damage from dicamba. But then as it gets more bluish, this means it's more damage and less healthy. So we're hoping to apply this in a very large scale and be able to collect more precise and in larger quantities of data. And once we collect all the few data available, the next step in this research is really to apply the genetics and all of the molecular studies that we have available and try to identify what are the genetics regulating this tolerance. And once we do that, our final goal is to make this superior tolerant lines available to all the farmers. And talking about genetics, one of the biggest indicators that we have that this trait is actually genetically regulated is the segregation we have been observing in progeny rows. So pretty much what we did is cross a tolerant parent with a susceptible parent. And we've been observing on the progenies segregation to the trait. So as you see in this picture here, one of the sister lines is susceptible, but one of the other sister lines is tolerant. So the progeny is segregating for the trait. And the same effect has been observed in 2020. So we have one of the sister lines highly tolerant, and then another sister line, highly susceptible. We're also exploring exotic germplasm, so lines that are coming from several different locations. We have lines from the US, we have lines from Russia, China, Brazil, Japan, all over the world. And we're growing those lines here and exposing them to off-target dicamba and seeing how they respond. And we're actually very excited to see that some of those lines they have enhanced response to dicamba, like this tolerant PI, no damage, but we also have some of them that are highly susceptible. So at this point, you're probably wondering if this provides any yield benefit. Does this secure yield at any point, or is this all cosmetic? Well, the data we got from 2019 says that it does provide actually a very significant yield protection. So if you look at the tolerant lines, let's call the 1 to 1.5 are tolerant. Those lines are on average yielding about 90% of the Xtend check, so 10% yield loss. But when we look at the highly susceptible lines from 3.5 to 4, those are yielding about 53% of the checks. So we're talking about a 47% yield loss. This is very significant and may reflect in several bushels an acre by the end of the year. So I believe this covers most of what we have going on and some of the preliminary results we have. I hope you all enjoyed this, and if you have any questions, please feel free to contact me by email or phone or on LinkedIn, and I'll be more than happy to answer any questions you may have.